We start Unit 8 today looking at operations on functions. The learning targets for this one is that you could add, subtract, multiply, and divide polynomials and functions, and that you can find something new called composition of functions. The first example on your sheet has a birdhouse, and it says Carol owns a store where she sells these birdhouses. The revenue, okay, that's a term we're going to need to talk about, from a birdhouse sales is given by this function. The cost of making birdhouses, okay, so this is cost, is given by this function. How would you find the profit that Carol earns on her sales? So when we start talking about profit, cost, and revenue, profit is the amount of leftover money you have when you take your revenue. Revenue is like all the money that comes in minus all your costs. So that might be like materials and that kind of stuff. So revenue minus cost gives you your profit. Hopefully your revenue is more than your cost and you make money. If not, you lose money. So they want us to write a profit function for Carol's sales. So we want to take these two things to find our profit. So our profit here is going to be our revenue, which they told us up here is this function, 125x, minus cost. And our cost function is the one they gave us here. Okay, now you guys have done these before. In order to do this now, we're subtracting two things. Okay, when we subtract, we want to make sure we subtract both. So what we did earlier lessons is change this to a plus and then change the sign on both of these. Now we're adding together and we've subtracted because we've changed these signs. So our profit function then is going to be 125x plus negative 65, so that'd be like minus 65x, plus negative 5,400, which would be like minus that. So now we just have to subtract these like terms and we have our profit equation. Our profit equation would be 60x minus 5,400. That would be our profit function. So if we knew how many x's or how many birdhouses she sold, times that by 60 minus 5,400, and you have your profit. Okay, so we're going to be working with functions, doing adding, subtracting, multiplying, dividing. You're going to see this notation that's listed here, okay, for plus. Okay, what this means, this notation means is f of x plus g of x. So we want to add the two functions together. Okay, this x right here does not mean add them in times by another x. It's just another way of writing f of x plus g of x. So for this example here, if this is f of x, this is g of x, we would write that this would be x plus 2 plus 3x. So we want to add the two functions together, and we would get, it looks like there's some like terms here, so 4x plus 2. All right, this next notation, difference. Difference means to subtract f minus g of x. That means f of x, the first one, minus the second one, g of x. So here, that would be x plus 2 minus 3x. Okay, so if we subtract the like terms here, 1x minus 3x is negative 2x plus the 2. That would be the difference of those two functions. Product means to multiply, so this notation here means f of x times g of x. So we want to multiply them. Here that would be x plus 2 times 3x. You guys have done these before. We're just distributing. So if we distribute to both, we get 3. Now we're multiplying x times x. Power gets bigger. X squared plus 6x. Okay, the last one, quotient. Quotient means to divide. So here we're taking f of x divided by g of x. On this problem, that would be x plus 2 divided by 3x. And that's the answer. Another way we could write this if we wanted, since we just got one term on the bottom, is we could write this as x over 3x plus 2 over 3x. And we could simplify in this one. Looks like these two x's would cancel out. So another way we could write this if we wanted would be 1/3 plus 2 over 3x would be another way of writing that. You could do that if you want, or this would be fine too. All right, so we are going to just practice some more of these, looking at how you add, subtract, multiply. So on number 1a, looks like this one's a plus 1. In order to solve this, we want to do f of x plus g of x. So if we look, f of x is this function, g of x is this function, put those functions in. Adding's easy. All you're looking to do is combine any like terms. So if we start with our x squared, that's the only x squared term. We do have a couple x to the first power degree 1 terms. Negative 3 plus 4 is 1x. And then if we combine our two constant terms here, that would be plus 6. That new function does the same thing as f and g added up. All right, next one, D. Now we got a subtraction one, so we want to do the same thing. This is going to be f of x minus g of x. So we want to subtract this first one minus the second one. Okay, so the easiest thing to do on these ones, if it's minus, is turn it into an adding one like we just had. So change the negative to a plus, but then you got to go through and make sure you change the signs on everything behind that subtraction sign, or it's not going to work out. So now we have x squared. Looks like, again, we have some like terms here. Negative 3 plus negative 4 is going to be negative 7x. And then we have 1 plus negative 5. That's going to be negative 4. So that would be the solution for that one. That new function does the same thing as f minus g. Okay, number 2a. Now we got multiplication, so here we want to do f of x times g of x is what that's saying to do. So we want to take this function times this one. Okay, if you're multiplying, now you got to go through and distribute. So we want to start by taking x squared times both of these. And again, when you multiply, powers get bigger. So this is going to be 3x cubed now because we got x squared times x minus 2x squared. Now we got to distribute the next thing. 5x needs to get multiplied to both. So we got 15x squared because we got x times x minus 10x. Okay, now take the last thing and distribute. So we got minus 3x, and now we got negative 1 times negative 2. That's going to be a positive 2, because when you multiply two negatives, you get a positive. Now that's the answer, but you should check. Is there like terms? Yeah, we got some like terms here. Put the like terms together to get your simplified answer. So we get 13x squared minus 13x plus 2. That would be the simplified solution to that one. Okay, B. They want us to do some division now. So with division, now we're just taking f of x divided by g of x. So our f of x equation was x squared plus 5x minus 1. Our g of x equation was 3x minus 2. You could check to see, do either of these factor? I don't think either of these, there's nothing that multiplies to 1 and adds to 5, so I don't think there's any simplifying we can do on that one. That would be our answer. All right, number 3 on the back. This one now, kind of a word type problem you might see on the ACT type question. It says this first function f represents the length of a rectangle. This function g represents the width. Write a function that gives you the perimeter. Well, think back to geometry. Perimeter of a rectangle is going to be 2 widths and 2 lengths, because you add up all the sides to find perimeter. So it'd be 2 lengths plus 2 widths. So if we plug in the functions for that, the length function is this one, plus 2 times the width function is the second one, 4x plus 25. If we solve that now, that should give us the answer. Both of these functions need to get doubled or multiplied by 2. So we need to distribute out here. So you get 10x squared plus 6x minus 4, and now we got to double everything in the second one, 8x plus 50. Last thing, combine like terms. We do have a couple like terms here. 6 and 8 would make 14x. Negative 4 and 50, same as 46. That function, now if you plug in x, would tell you what the perimeter of that rectangle would be. Okay, we're going to kind of review a couple things here with finding the value of a function at a certain location. So for A, they want us to know what is function f evaluated at 2. Remember, when they have a number there, that means plug that number anywhere you see x for f of x. So f of x here is the equation x plus 3. So if we want to find f of 2, that means in place of this x, plug in 2. So f of 2 would be equal to 5. That means the point 2, 5 is a point that this graph goes through. Okay, let's find g at negative 3. That means our function g here is x squared plus x minus 1. Anywhere we see an x, we want to plug in negative 3. So figuring this out, negative 3 squared, negative 3 times negative 3 is positive 9. Minus 3 minus 1. 9 minus 3 is 6. Minus another 1 would be 5. So that comes out to be 5. That means for function g, the point negative 3, 5 is the point the graph goes through. Okay, let's look at C. Okay, this is kind of a new thing now. We got f g at negative 3. So this is kind of new. You've done problems where you've had parentheses inside of parentheses. Anytime you got parentheses inside parentheses, start with the innermost thing. We want to start here. What is g at negative 3? Well, we just found that out. G at negative 3 ends up equaling 5. Okay, we just did that problem right here. So what we can do, once you find out the middle one, is replace whatever that is with what you find out it is equal to. So here we're going to replace the g at negative 3 with the value of 5, because that's what it's equal to. Well, now to complete this problem, we got f at 5. That's just a problem like we did above. Plug in 5 in for function f. So function f is something plus 3. We're going to plug in for that x 5 to figure out the answer here. So the answer comes out to be 8. 8 is what you would get. So kind of with the process, what we just did is we started with some number x. We plugged it in for function g. Out of that, whatever that comes out to be, we plug in for function f, and what comes out is the answer. So you're just kind of going through one function, through another function, and out comes the answer. All right, let's try D here, another one of these. So on D, we want to start again, innermost thing. We're starting with this. What is f at negative 1? So let's figure out what we get when we plug negative 1 in for function f here. So f at negative 1, we're going to have negative 1 plus 3. That's going to equal 2. Okay, so what we're going to do now is in place of f at negative 1, we're going to replace that with 2. So now we want to find what's g at 2. So in function g, we're going to, anywhere we see an x, we're going to substitute in 2. So we got something squared plus something plus 1 is function g, or sorry, minus 1. Anywhere we now have a parentheses or what was an x, plug in 2. So whatever this comes out to be should be the answer. We would get 4 plus 2 minus 1 is 7. 7 is the solution. When you go from one function through another function, like we just did, there's a name for this that's called composition. So what we're doing here is a composition of functions, but composition basically means substitution. So we got 2 more of these composition ones. These ones are a little bit different now because now we see no numbers involved. There's not any numbers in E. It's just all not letters, all variables. But the process is the same. We want to start here and with our function f, and what's getting substituted is g of x. Okay, so what this is going to look like now is function f is something plus 3. What we're going to substitute in for x is g of x. Okay, but we're not going to stop right there because we know what g of x is. G of x is equal to this function. So now we're going to replace g of x with the function that it's equal to, x squared plus x minus 1. Now this just looks like a problem we were doing on the front of your worksheet. We want to combine these two things together. So there's only one x squared term, there's only one x term, but these two constant terms we can put together. Negative 1 plus 3 is 2. This function right here now does what the composition of these two would do separately. Okay, let's look at the next one. This one's the same functions, just the other way. Okay, so this first one that we did would start with x. We would go through g first, then we would go through function f, and out would come the answer. This next one goes the opposite way. We start with our x, we plug it in, but now we're going to be plugging in, whoops, sorry, got this backwards. This would have been plugging in, oh yeah, never mind, I had it right, g into f. This next one, since we go inside out, would be starting with function f, then going through function g, and out comes the answer. Okay, so let's look at this, what this one would be. G, function g is something squared plus something minus 1. We're substituting in f of x. We know what f of x is, though. It's x plus 3. So let's replace those with x plus 3's. Now we want to see what does this simplify to. Now on f here, be careful with this first part, x plus 3 squared. When you see a plus or minus, we can't just say that's x squared plus 9. That is incorrect. You'll get that wrong every time if you do that. And the reason is there's plus in here. Anytime there's plus or minus and you're squaring, you got to multiply out 2 of them. We got to FOIL this out. X plus 3 times another x plus 3. So if we multiply that out, that's x squared plus 3x plus another 3x plus 9. And then we still have this x plus 3 minus 1 on the back. So if we combine like terms, our answer is x squared. I think we have a total of 7 x's there. And then 9 minus 1, or 9 plus 3 minus 1 would give us 11. This function, it would do the same thing. Now notice it's not the same as the other one because we're going through one function then another one, but it's different than on the other side. So all this stuff we were just doing, that's called a composition of function. Composition is similar to substitution. It's just a different name for it when you're dealing with functions. Okay, now we were just using this notation. One other notation you may see, ACT has used this before, is this notation for composition. It's almost like a little degree sign, but it means the same thing. F composed with G, another way you can write that is this. So I think most people are more comfortable with this notation, but if you see this on the ACT, that means the same thing. So with this example here, they want us to find what's F O G. What that means, they want you to find is F of F composed with a G like this. So with the two functions they gave us here, we're starting with F because that's on the outside. So it's something squared. What we're squaring here is function g of x. We know g of x is 3x plus 4. So if we square 3x plus 4, that would be the solution. This is one we're going to have to FOIL out again because we got a plus in there. So the answer would be 9x squared plus 12x plus another 12x plus 16. And the total solution then would be That would be the composition of these two functions. You're going one function into this machine that brings out this, and then it brings out something else, and you get a composition of functions. Let's try one last one of those, because this composition stuff's kind of new. What's this going to equal? Find f composed with g with these two functions. Why don't you pause the video, try this one on your own, and see what you get. All right, let's see here. F, we want to start with function f. Plug g in place of that, substitute it in. So function f is 3 times something squared minus 4. We're substituting in g of x. We know what g of x is, though. It's that. So it's 2x minus 1 squared minus 4. If we simplify that, that should give us our answer. Minus is like plus here. That means if we're squaring that, we got to be foiling out 2 of these or multiplying 2 of these out together. So here, if we multiply that, that's 4x squared minus 2x minus another 2x plus 1 because it's negative times a negative. Now we want to times everything by 3 because there was a 3 outside of that. So you got 12x squared minus 6x minus another 6x plus 3 minus 4. Last thing, combine like terms. We got 2 sets of like terms here. So final answer would be that function. All right, why don't you try some of this adding, subtracting, multiplying in this new one composition out now on your practice.